Excellent. Welcome, everybody. It's wonderful to have you here, both people here in the room and the over 400 people we have online with us today. I'm Jordan Green. I'm the chair of the Victorian Pearcey Committee and on the National Board. I'd like to start off by acknowledging the Pearcey Foundation would like to acknowledge the Boon Wurrung and Woiwurrung or Wurundjeri people of the Kulin Nation and all the traditional custodians who belong to the lands where the Pearcey Foundation and you, our guests, wherever you are meeting, living and working. We acknowledge the Aboriginal and Torres Strait Islanders, the people who are with us today and their elders, past and present, whose traditions, stories and living cultures in this country are a valuable resource, as are those of all who have come to make Australia their home. Together, we are Australia. I'd like to welcome you all to the DIF discussion in the discussion series for Australia 4.0. Australia 4.0 is an initiative by the Pearcey Foundation to have a discussion about the intersection between the transition of our electricity system to net zero and the opportunities for the Australian ICT sector to enable that transition to happen and create new business opportunities and new success for our community here and abroad. This session is a feature of the 2003 Digital Innovation Festival, and we'd very much like to appreciate and recognise the support we're receiving from the Digital Innovation Futures team at the Victorian State Government. I'd also like to acknowledge that we're here today with the ACS. The ACS are partnering with us in the delivery of this event, and the ACS hub in which we're operating is also part of the Digital Innovation Festival program. I'd like to acknowledge a few of the key people in the room. I'd like to recognise Wayne Fitzsimmons, OAM, who is the chairman of the Pearcey Foundation. And I'd like to recognise Rob Dilnut, who is the chair of the Victorian chapter of the ACS. And at this point, I'd just like to apologise that we're going to be down one panellist today. Mario Tiepo has had to pull out at the last minute due to some health issues. So we do wish you, Mario, all the very best and hope that everything works out just fine. So with that, I'd like to introduce our moderator for the day. Patricia Boyce is the chair of the Centre for New Energy Technologies, known as C4NET, which delivers data-driven research in collaboration with government, industry and academia to assist the rapid transition of the energy sector. The centre is an independent, member-based, not-for-profit company with an area of focus on local energy systems, spanning distribution networks to consumers. Earlier this year, C4NET launched its flagship project, Enhanced System Planning for Victoria. With the support of the members and supporters of the organisation, it's intended that this will inform sub-transmission planning from 2030 onwards. So with no further ado, I'd like to introduce Patricia.
Thank you, Jordan. And I think the rest of the panellists should join me at this point up on the podium. Today, the three of us, or the four of us, I guess to ask the occasional question, are here to discuss whether there is a role for the internet in the transformation of the electricity grid to net zero. Specifically, we're here to discuss whether the existing telecommunications infrastructure supports the needs of the next generation electricity distribution and transmission networks as Australia transitions to a net zero emissions world. We have three panellists here today with deep and diverse expertise in the electricity system, related, and last week's discussion, which I attended online with considerable interest, the increasingly linked sectors in water and telecommunications, and the commercialisation of research-based technology and the implementation of digital transformation. Across their presentations, the panellists are presenting the challenges, potential solutions and opportunities for the ICT industry in the transformation of the electricity grid to net zero. Initially from the perspective of the electricity industry, Some of the discussions in this series to date have been from the electricity sector's perspective, but some of them have been much broader. We're also moving out from the perspective of the energy sector and bringing into play broader considerations. In particular, how do we want the future we're heading towards to play out? I think you'll agree that what the panellists have to say suggests there's no end of opportunity for the ICT sector and for the internet in the transformation of the electricity grid to net zero. And that role could be transformative for all of us. Following the panellists' presentations, I'm looking forward to a lively, contended and respectful discussion between the panellists, those of you in the room and those of you online. But I'd like first of all to start by welcoming our first speaker, Ina Kulwiecki, who's the Vice President Business Development, Worley. Ina's considerable experience spans commercial and operational roles in the electricity sector as an advisor, an operator and a leader in the Australian and Pacific sales operations for a global wind farm equipment supplier. Today, Ina's exploring the dimensions of AEMO's hydrogen superpower scenario, the implications for communications, digitalisation and data transfers of the major remote projects that form part of that scenario, and queries our readiness for the scale of the development required. Ina.
Yep. Thank you, Patricia. Thank you all. Thank you, Pearcey Foundation, for this opportunity to present my views on a certain unexpected progression of the grid and the roles that ICT industry can play here. So if we go into the next slide.
You got, no, here.
Okay,
Here.
cool.
Yep.
Beautiful. I love this chart. So this is AEMO Integrated System Plan 2022. So it's the latest one released, and it explores different demand scenarios in the NEM. So the most expected one, and the ones that's been very widely discussed, is the step change scenario, and it's got 50% probability of occurrence. The one that I want to talk today about is the hydrogen superpower scenario. It's not the expected case, but is that the case where we want to be? Is that the case where the innovation is really going to be driven? This is the case where there is a real opportunity, not just for the energy industry, but for the adjacent industries, including ICT. Just a bit of a background on the step change scenario. It's a rapid consumer-led transformation. We expect almost doubling of the electricity delivered through the NEM to 320 terawatt hours to serve the electrification of our transport. That growth is in addition to significant ongoing investment by consumers in distributed energy and energy efficiency, coal-fired generation retiring with 60% of capacity withdrawn by 2030, nearly 5 times the distributed PV capacity, and substantial growth in energy storage, and 9 times utility scale renewable energy. What does hydrogen superpower looks like? Well, hydrogen superpower it requires a significant global action and significant technological breakthroughs and innovation. It nearly quadruples the NEM energy consumption to support hydrogen export industries. The technology transforms transport and domestic manufacturing. Renewable energy exports become a significant Australian export, retaining Australia's place as a global energy resource. Households with gas connections will switch to hydrogen gas blend, and it will require development of significant projects to support that hydrogen export industry. And just to talk about some of the projects, which most of you have probably heard, is Australian Renewable Energy Hub, Green Hydrogen Energy Hub, developed by Intercontinental Energy. Just those 2 projects are 76 gigawatts in capacity. That's pretty much an entire NEM today. So what are going to be the challenges for the ICT industry to deliver that? And this hydrogen superpower scenario is the only scenario consistent with limiting global warming to 1.5% degrees Celsius. So it does require significant advances in digitalisation trends and significant innovation and technology breakthroughs. So this is really an opportunity of a lifetime for the industry. So just looking for some of the other trends and questioning, well, looking at trends of the global, they're global trends. Number of IoT devices, I mean, they're looking to double over the next 6 years. The data traffic is looking to triple over the next 4 years. I mean, do we see an opportunity there? Absolutely. Just imagine the opportunity with the hydrogen superpower scenario, where we are quadrupling the NEM capacity, where just 2 projects that are being built are the size of the NEM today. So what kind of innovation would we require to basically build a NEM from scratch? Western Green Energy Hub is a 50 gigawatt project. It covers 15,000 square kilometres of land. This is solar and wind and hydrogen facilities. Those are huge. This is where the opportunities are. I thought I'd also look at it from a financial perspective in terms of where the investment is required for the hydrogen superpower. So the first line is to reach the net zero requires 300 gigawatts of wind and solar and requires over 400 billion of investments. That's our step change scenario. And then we're moving to 740 billion investment and 112 gigawatt of wind and solar for the hydrogen superpower. But this is just the generation sector. Looking at how do we transition there, we're actually looking for a requirement of investment of nearly $3 trillion, and that's Australian, 1.9 trillion US dollars is required to implement the hydrogen superpower status. And if you look at it, the grid's investment represents 16% of it. So there is also opportunity in adjacent sectors. Obviously, there's a low carbon power. This particular scenario looking at CCS supporting the fossil fuel generation. EV sales represents more than half. That's transport, that's vehicles, that's building those charging infrastructure. It's huge. But achieving the hydrogen superpower scenario means that Australia will be capable of supplying 6% of this expected global low-carbon hydrogen demand. So that means we are going to stay as an energy export resource for the global community. And this is, economically, this is where we want to be, obviously. I mean, this is a huge opportunity, but it's not without challenges. And some of the challenges are around increased digitalisation and the use of AI. Well, I shouldn't really be saying challenges. It's probably more of opportunities for this sector and where we can go. So again, electric vehicle infrastructure. On the previous page, I've mentioned the spend required between now and 2050. Public engagement and awareness. I mean, social license to operate. Where do we build the transmission infrastructure? It's Indigenous engagement, knowledge sharing, attracting talent where it needs to, as well as data connectivity, cybersecurity, remote monitoring, smart grid, distributed energy resources. Niluksha will cover those in more details. But just going back on, just to give you an example on increased digitalisation and use of artificial intelligence, according to a PwC report, AI will potentially contribute over $15 trillion between now to the global economy between now and 2030. And currently the key beneficiaries are healthcare, maintenance and component suppliers. So how do we make sure that transition to net zero really benefit is benefited through the use of AI. That is it from me. Thank you.
You're saying, may you have the opportunity of a lifetime, and that's a scary thing to wish for people.
Absolutely.
Thank you, Emma. Our second speaker this morning is Lushka Harris, an energy industry professional who brings her considerable experience as a power systems engineer and energy industry leader with a diverse employment history to this discussion. Following on from Ina's presentation, Anushka will be exploring the implications of future scenarios for the pace of transformation for the energy sector's expectations of the ICT sector. As the case studies she'll be talking about illustrate, the future's already with us, even if the scale and complexity of the shift towards the future electricity grid are underestimated right now. Anushka, now.
Thank you, Patricia. Thank you to everyone here today and also online. And thank you to the Pearcey Foundation for this opportunity for me to speak to you about this important topic. So I'm here today speaking with you as a professional in the energy sector. And one thing we often hear about in our sector is that Australia is experiencing one of the most fastest and most profound energy transitions in the world. And there's obviously a lot of reasons for this. We've got the resources, we've got the technical innovation, the economics, some of the policies, and obviously we've got our generation plant that's retiring on the grid, and also consumer choice that's changing. But really with this transition comes many opportunities, as Ina suggested, for us as a society to come together and really create a pathway for this energy future. And one thing we also know in this sector is that we're not the only ones in the world that's going through these sort of challenges. They're being experienced around the world. As Ina spoke to earlier, the 2022 Integrated System Plan looks at 4 core scenarios for the pace of energy transformation to net zero by 2050. And at the time that the ISP was developed, stakeholders felt that the step change scenario was the most likely of those. And that scenario considers 83% of the energy supply being met by renewables by 2030. So when you're looking at a power system that's got that sort of very high levels of renewables, variable renewable energy sources, and also things like electric vehicles and flexible loads, it will be very dynamic and complex, to say the least. And when I'm talking about a power system, we also need to think about it as a network of structures. What I mean by that is that, if you look at the illustration that you can see on the right-hand side of that slide, this is an illustration from StratGen that is looking at how that multi-structure network could actually evolve to meet the needs of the step change scenario. It consists of various sets of infrastructure. So you can see the electricity infrastructure, the digital, the SCADA, all coming together with the various structures. So the operational structures, the market and transactional structures, with lots of interdependent links between them that form links with the actual physical assets and the various players that are involved, or the actors. I won't go through much more detail than that, but really it's to show that as this, over the coming decades and beyond, when you're thinking about all these subsystems and actors and all the complexity of coordination between them, really the complexity will only just increase by orders of magnitude, particularly if you're thinking about some of the more aggressive scenarios like the hydrogen superpower scenario that Ina touched on earlier. So this is really to sort of further add to what Ina's talked about in terms of the scale and complexity of what we'll be needing to deal with going into the future. Okay, so what does this mean for the role of the internet in enabling net zero? Ina's already covered some of these items already. What I will do today is actually go to the heart of some of these items, in particular the ones that you see on the slide in blue. And I'll talk to them in the context of examples of what we're actually seeing in the energy sector today, the sorts of things that we're exploring now and into the future, and what that could mean for opportunities for the ICT sector. So I'll focus on data connectivity and sharing, remote monitoring and control, in the context of DERs, or distributed energy resources, and also cybersecurity, just to sort of talk to you about some of the case studies there and the opportunities that come with them. So just to start off with data connectivity and sharing, the example I'll give here is in the context of distributed energy resources and how they're applied in the context of virtual power plants, and with specific reference to a couple of projects that are currently underway. So just before I continue, for anyone who is not aware, DERs, or distributed energy resources, are essentially devices that are connected to your homes and businesses, and they have the ability to actually produce electricity, or the smarts to manage demand. And really the intention with these virtual power plant pilots or trials, these projects that I'm talking to here, is to look at ways to actually look at how fleets of DERs could be aggregated in such a way that you can actually create a working energy marketplace. So this is different to the wholesale energy market that's currently operating, but there are basically trials or proof of concept projects that are looking at grouping fleets of those DERs in a way that they can actually be aggregated and orchestrated to provide either wholesale services or local distribution services and get paid for those services. So the two projects I'm referring to here are Project Symphony, that's a project in WA that's currently underway, a trial that's looking at about 500 customers in the Southern River area, and also Project Edge, which is here in Victoria, in the Hume region, that's I think over 1,000 customers. And so this not only allows those consumers that own those DERs to access and provide electricity services, it can actually also help market and system operators to enable better visibility of those DERs and to be able to control and operate the power system in a secure and reliable way. On the right-hand side of that slide, you can see that that's the actual communication chain that exists within the data exchange hubs that are used to operate those virtual power plants, and those data exchange hubs specifically refer to those particular projects. And I'll just briefly touch on how it works at a high level. So the DERs themselves are essentially those IoT devices that you see at the bottom, and the aggregators essentially aggregate those DERs at a portfolio level, and with the help of the agreements that are already made with the consumers that own those DERs, they access and deliver electricity services on their behalf. So then the aggregator offers bids to the market and system operator, coordinates with the actual distribution network service or the service operator to make sure that all of that remains within the technical operating envelopes of the network. And then the market and system operator then dispatches instructions back to the aggregator so that the aggregator then can control the DER devices. So all of this happens in a data exchange, and there are telemetry signals that are sent back and forth for the offers and the dispatch signals and so forth. And one of the recent learnings from the Project Edge is that the faster some of these telemetry signals are, the less the coverage because of some of the latency issues that are experienced between the aggregators and the IoT devices, for example. And that could sometimes simply be because the IoT devices are in someone's home in a remote location, and the Wi-Fi issues are causing that latency issue. So that's just what I guess I'm trying to highlight here is that these projects or these trials and proof of concepts are really, the purpose of them are to try and capture learnings like that, and to really look at what are the opportunities in terms of what this means for the future of our grid. As more and more, we have more and more aggregators, perhaps more and more networks and millions more customers with these sort of devices connecting to the grid. And the other thing is that when you have this sort of communication latency issues and things like that, it actually does affect the value to the customers at the end of the day as well, because the slower these or the slower the information or the higher the impacts to the actual quality, it might also mean that there are issues to the actual speed of the pricing signals that are sent to the consumers, for example. And that means the aggregators themselves have to spend more money to invest in the architecture to be able to enhance these systems and make them work better. So at the end of the day, it does affect value to consumers, and that's important because ultimately that's what we're trying to maximize with these type of projects. So really for the opportunities for the ICT sector, it's about looking at obviously the technology to make sure that they're reliable and secure and safe, as well as the actual communications protocols and standards that underpin them, to make sure they're actually fit for purpose, because obviously they are very different to how the current markets and systems work today. So as for my next example, I'll talk about remote monitoring and control. So in the electricity system today, SCADA, or supervisory control and data acquisition systems, are used quite widely and commonly to secure data, supervise and monitor the power system from remote locations. And since January 2021, there have been 5 SCADA failures that have impacted the market and the power system operation across Australia. And I've just used an example here, but one of the examples was earlier this year, where AusNet Services, who owns and operates majority of the electricity transmission network and parts of the distribution network, had a firmware issue at one of their data centers, and that meant that they actually lost visibility of a lot of their assets. And consequently, there was a need to actually suspend the electricity market here in Victoria for a couple of days. So it just goes to highlight the importance of these, systems in us being able to actually operate the power system and our markets. And particularly as these systems and network of structures grows, really there's a very important need for us to make sure these systems are reliable, not just for today, but into the future as well. On the right-hand side, I wanted to talk about something we're looking at that's new and different, I suppose. So whilst we do use SCADA systems for a lot of our monitoring and control functions, the reality is that as we connect more and more renewables into the grid, and particularly variable renewables, we're starting to see different types of issues on the power system that need to be monitored. So there could be things like frequency response due to different types of events that we need to keep a careful eye on, or it could be the inter-area oscillatory events and also system strength or inertia events. And whilst I don't plan to go into detail on what these issues are, the point I want to get across is some of the SCADA systems that are currently being used, they don't actually provide sufficient availability or ability for us to actually monitor and control the systems of today. And that could be because the SCADA systems the data that comes from those SCADA systems might not be time-stamped, or there could be delays across networks, or the resolution itself is not adequate. So as an industry, we're looking at ways to actually alternate technologies to help us that detect, monitor, and respond to events because of the changing nature of the power system. And one such device type of system that we're looking at is wide area monitoring systems, and particularly phasor measurement units, and they're currently being deployed and upgraded across our grids and markets to actually help us detect and monitor and control some of these issues. So in terms of the opportunities for the ICT sector, this is again about making sure that the technologies are reliable, available, they have sufficient restoration times, and we're also thinking ahead into the future about what the future needs of the electricity system are and how we can cater for them in terms of technology. Just finally, I just thought I'll touch on cybersecurity. So obviously cybersecurity is quite topical, has been in Australia in the recent months, and there's been a number of sectors that have been affected by cybersecurity. But yeah, in the context of the energy sector, look, I think it's fair to say that what we're trying to do in the energy sector is keep the lights on most of the time. We're trying to maintain secure and reliable supply. And if there were to be a cyber threat that, say, for example, causes a widespread blackout, that could have long-lasting impacts, not just for the economy, but also for livelihoods potentially as well. So we're talking about critical infrastructure here, and protecting the energy sector from cyber threats is really of national significance. So one case study I wanted to just quickly touch on is CS Energy, that you may be aware. They had a ransomware incident on their ICT network in November of 2021. There wasn't any impact to their generation plant. So for those of you who don't know, CS Energy is an energy company, a government-owned energy company in Queensland. They own some generation plant, particularly coal-fired plant. There was no impact to that plant, but there was impact to their corporate systems of workstations, servers, databases. Unfortunately, they were able to get on top of that, but really this just highlights the need that no sector is exempt from this. There's really very much a need for ongoing enhancement of internet infrastructure and environments to safeguard our energy sector from evolving cyber threats across Australia. That's all I had to cover. I think probably fair to say that the internet will play a fundamental role in creating a more sustainable future for us, and that enhancing the role is not just about solving some of the problems I talked about and technological innovation, but it's also about the ICT sector coming together with the energy sector and our policymakers and other stakeholders to really focus on how we can collaborate better to solve these issues and challenges. And hopefully my examples suggest that we're not talking about 5-10 years from now. The future is actually here, and that we all have a very important role to play. Thank you.
Thank you, Nilushka. I think you've got my introduction to Jennifer. Yeah, it's okay. I think the latency question is one that in the context of this discussion will be interesting to explore in question time, because if you can't get the required response times with standard comms, is there a value proposition for going to dedicated comms? And speaking as an economist, I think that's a kind of material question, but one for question time. Our last speaker today is Jennifer George, that some of you who will have attended the earlier sessions will have already met. Jennifer's the CEO, Strategic Commercialisation Australia, and the co-chair of Australia 4.0, the Pearcey Foundation initiative to identify and build ICT solution for Australia's net zero grid. Pearcey, of course, is the group bringing this discussion to you today. Jennifer's particular focus today is the implications of bringing other sectors into the electricity system, and she's defining the electricity system very broadly. What are the implications of moving other sectors inside the net that we think of as the electricity system for the way in which that system might function tomorrow, and for the opportunities that this presents us to design the future communications we want? And she did say, if I needed to cut to the chase, that the focused description of her message would be location matters. Jennifer.
Thank you, everyone. It's so great to see you all, new friends. and old friends. And it's great to be part of the Australia 4.0 with Wayne and with Jordan and with Colin, of course. And thanks for ACS for bringing us in here today. So my discussion here is about the idea of how we're going to pull this together really matters in terms of where it is, right? So whether or not the internet will work or whether it will solve the problem will be largely a matter of what location it was in. So this isn't a scientific paper. It's something that will provoke conversation, hopefully. I'm taking a more broad perspective because I work on constantly with innovators. And so creativity is part of what I do. So if we think about what's happening with renewables, everything is really being distributed to the regions. So for when the location matters, how do the regions matter? So, so here we go. So is there a role for the internet? So here's the Australian internet, the telecommunications coverage and the energy transmission coverage. And you can see it pretty much looks the same. I mean, any logical person would say, oh, yeah, it's going to work. For sure it's going to work. You know, everything kind of matches up there. But the reality is that in the regional world, we only, we have 60% of our rural and Indigenous people without internet coverage. So if we're building a grid or bringing comms into the regions, we really need to understand that some of the people wouldn't be able to access that, and some of the regions wouldn't be able to access that. So we will need to build new infrastructure for those telecoms in order to make them work, which is kind of interesting because we could not only make them work for the grid, we could make them work for the people. So if we see a shortfall, so where we put the new technologies, where we build the new renewables, really matters. We have a potential here to make a difference. So that's the general grid, but the reality is 90% have slower speeds than urban people. Now, as urban individuals, we think to ourselves, well, you know, of course we're going to put the internet there. Yeah, it's going to work, right? Not necessarily, right? If 90% of people have slower speeds, then what Patricia said, latency could be a substantial problem. And also we have the issue of what kind of service are they using? Are they going to use satellite services? Are they going to use broadband? Are they going to use the various telcos in the way that they work this? The location matters. So now let's just think about the overlap here between bringing everything into the regions and the fires and floods that are within the region. You'll see up there in the bushfires that go across Australia, they're also in that same region, right? And you know that smoke is going to always cause trouble with your wireless coverage, right? So that's the problem. Down the bottom, you'll see a picture of the floods. This is a picture of the release of water from the Forbes area dam, and it was 1 billion litres of water. So when we talk about you wanting to use, you know, masses of water, is there a way that we could actually capture this water? How could we manage floods better? How could we get ahead of that because we've got interconnected systems and actually use them to create new industries? So creating an interconnected bond of technologies. Will 5G help? Well, probably not. We can put 5G into a local internet system that surrounds our generation systems and any of our transmission systems, but ultimately 5G will have to go to the transferring system. So it won't be 5G all the way. So obviously low latency and 5G is very important and it has a lot to offer, but the way the autonomous vehicle industry has really solved this is because they had this issue around should it be connected autonomous vehicles or should it be edge computing, is to say, you know, it's got to be a hybrid. So basically in the grid, when we're talking about delays in service over long distances, we've got to say it's going to be a hybrid for sure. So let's make sure we build in redundancies, build in energy storage so that we can make sure that it actually works for us. So is there a solution? This is Patricia's slide. Because last time I did my presentation, Patricia said, is it all just problems? Have we really got something that is going to work here? So I'm going to give you a solution that's completely different to everybody else, right? It's not just about technology, and I hope people online give me lots of questions, because this is designed to provoke questions. So 100 years ago, we had thousands, if not millions, of acres of grasslands in Australia. And if we were to make a new civilization, they would look to add reliable energy, transport and communications, water, food, and all these different environmental factors which are now imposed onto our new development. Couldn't we, when building these green fields, stop and say, is it possible to build new communities as well? Could we not just think about energy? Or, don't tell me about that social stuff, love. I'm just building energy here. No, it's not just building energy. We are building new communities, we are building new generation, and we're building new responses for the future. So take a look at this. In this slide, you'll see 100 acres of land of solar on ground. And also on the right-hand side, you'll see a map. I think I have a little pointer, I think. Trying again. Yeah, there it is. No. Okay. Oh, I got a pointer. Okay, so there's this land here, this area here, is where all the grasslands really were, right? So you see that area, that yellow area, is just outside where the interconnectivity for the grid and the telephone systems, the telecommunication systems were. Also, take a look at the map beside it. That's where the main areas for the batteries, the potential for new minerals, critical minerals, and new technologies. So look at that black area right here. It kind of overlaps with that grasslands area. Right? If we to put all of that solar panel on ground, we have one use. We've shown one use for that solar panel. But the reality is solar panels have multiple uses. They can provide shade. They could be windbreaks. They could potentially capture water. So if we had 1,000 kilometers of solar, couldn't we do regenerative agriculture underneath? Couldn't we create something that would sequester CO2, and then we would sell our our carbon credits as one of the biggest exports that we have for Australia, in addition to hydrogen? So we have the two things together. This is another way to sell our sunshine. Okay? So what we're trying to do, currently the emissions, we're looking to, with all of these initiatives with the grid, we're looking to reduce the emissions that we deliver. And so we were transitioning to renewables, so hopefully it'll work. But what if we tip the scales even further? What if we also were able to increase our carbon sequestration at the same time, at a massive scale, not just like a little bit, but a lot. And we created a full-on industry about Australian carbon credits. This is really interesting because the value of a carbon credit has gone from $34 to $70 recently. And over the years, it's going to go up even more. Soil sequestration can potentially store 500,000 tonnes per hectare. So of soil over time, right? So there is some value in this, and that's what I'm saying. It's not a scientific paper, but think about it. Is there another way that we could investigate to put a number of things together to create communities for the future? So when we think about just building the grid or internet connectivity, we can integrate many new ideas because we're building the future. And that's really important. Thanks very much for your time. Thanks.
Now, we're going to get rid of the podium, but that doesn't, I think, need to hold us up if there are questions in the room. Gentlemen, are there questions in the room? All right, Wayne, you get the...
I'd just like to ask the leadership, I mean, that Jennifer mentioned about the latency times with 5G and in the vehicle-to-vehicle communications and so on. At some point you have to use direct communications, but then if you're going to use the 5G, 6G, inherent latencies. Can you give us some examples of where latency becomes a serious issue using existing infrastructure?
Be a lot of examples in the sector, really. When we're operating the markets and systems, I think it's already an issue on our control rooms. We've got a program where we're looking at, I think across the industry programs, looking at the technology side of things. And one of the main things that we're struggling with is just the amount of data that we're needing to really deal with on a day-to-day basis, both from the operations perspective, but also in terms of operating the market itself. And there are, various initiatives underway to try and look at that from different perspectives, not just from a technology perspective, but in terms of the processes and systems that we're using, the protocols and standards, and I think generally speaking that there are definitely a lot of issues around that day to day.
I've got another example if it helps. So if you look at the description of what DER might do, then included in the lists are things like power system stability, so an ability to respond to over and under frequencies, for example.
Yeah.
But they are millisecond required responses. And if, in fact, you're communicating through an aggregator to a household, the household could be being instructed to do something which is entirely counterproductive by the time it gets the instruction because of the latency in the system. Now, the problem is that ripping up what we've got, or alternatively requiring every household that has solar panels, for example, to upgrade its comms in order to facilitate this, is an expensive operation. The events are currently infrequent. The payments are, in consequence, that household will receive are trivial. The system requirement might be enormous, but the economic case for ensuring that households participate in this, as opposed to the existing set of service providers, batteries and generators, depends on how well and how cheaply you can manage and coordinate that response from the distributed resource. So the distributed resource is real, but whether you can mobilise it profitably for the households and cost effectively for the system is, I think, a live question. But I shouldn't probably say live question in this context.
May I add? So if you design a system and try to bring in new technology to solve that problem, you have a problem where that technology is ahead of the rest of the system, right? So my belief in the way this could be addressed would be that you would look at all of the different system requirements that require urgent, low latency transactions, and then you start to prioritize them. You look at things that absolutely have to have it, and then you start, and then other things that maybe could take a slightly longer time if you took a different approach, right? And then the other, so the really important ones that you have to have, then you look at how you can make those services edge computing or something that is very close to where the transaction is. But but then on the other ones, for the very long distance, assume then not that it's going to be able to be addressed really quickly. Build in redundancy, build in gaps in the system so that those gaps are filled with batteries and the system setup, rather than going from one to the other. Then you look at, okay, how can we make them at this a 3-spot system rather than a system where we're worried about this one thing reacting with the other 2 slowly. So create and build a system that understands that things at times will take longer.
So Jordan, do we have a question? Do
we have any questions online? Oh, excellent.
I had a question.
We have your name and...
My name is Rujuta, and I had a generic question, as in if like a working professional or probably a young professional is kind of excited about this net zero initiative, what would be some of the suggestions that you would like to give, or what would be some of the strategies or advice that you would give to that particular professional?
What is your interest? Are you looking to work in it? Are you looking to contribute to it? Do you have ideas?
Right. So I have a few ideas, and there is something that's coming up in the Salesforce ecosystem, which is pretty interesting for me. So it's called Net Zero Cloud. So I was just trying to understand what kind of initiatives or what kind of work is to be done in order to get into that space, and what kind of, how to probably get started with that particular initiative.
So jobs are going to be huge for this. Reskilling, adapting. So anybody who's interested and talented and already has some capabilities, welcome aboard. You're going to be somehow engaged with this. But it's up to you to take the initiative, to learn about it, to understand the problems. If you want to do this as an entrepreneur, then you need to get ahead and learn a specific sector so you can start to work out what your value proposition is for that business that you're going to do. But if you're going to do it as an employee, go to your employer, knowing about the sector, understanding the problems, listening to the 5 lectures that we've already had so far online, so you can actually have a really good grasp of it when you talk to them.
Yeah, and just to add to this, obviously, if one of my slides sort of showed where the money is, I guess, in this transition. If you look at greed, it only represents 16% of it. So have a look which space you want to play and where the spend is going to be. So
that's good advice.
Yeah, so follow the money trend.
Which other domains do you think would be like most appropriate or most aligned to this net zero initiative currently?
Anything. I mean, so what are your capabilities?
Currently, I have telecom health.
I mean, you know, looking at the grid and how it interconnects with hospitals, and how digital health is going to be all part of being the low latency deliverables of the future in the regions, it's immense. What we're talking about and what everybody here has talked about is a step change. So do your due diligence, learn it yourself. Put yourself in front of whoever you want to impress with a clear view of what you can offer for their problem, right? So I think you'll be fine.
And I'll just add to what everyone said already, there's a real issue around skills and the skills shortage in the industry right now almost, let alone what we need for the future. and there's a lot of work happening within the energy sector, at least, to look at workforce planning. And so I guess what these presentations will hopefully highlight is that it's not just the requirements of the energy sector, it actually has multi-sector impacts. And that just means that the opportunities are limitless. It really comes down to what interests you and what drives you. And yeah, artificial intelligence, cybersecurity, name it, there's so many different opportunities out there. And I would agree that it would be a great thing if everyone, students and young professionals really engage in these kind of discussions and learn more about them as well.
Absolutely. In my session that we had, that's the one before this, the three speakers mutually agreed that awareness, understanding of the topic was one of the key things you can do as an individual, and how we can drive this discussion further forward. So, and the other thing I want to go back to, Barack Obama once said that if you want to go and work for somebody, bring them your solution, don't bring them a problem. So if you can be a solution, kind of understand this to such a level that you can start to understand that these are the ways we might solve it together. Even if each one doesn't exactly work, you'll be in a really good shape.
Oh, we've got someone else in the room. And
Well, why don't we take one from online
Sure.
first, and we'll come back to the room. So let's see, we've got Gavin Walker from Data 61, who's made the observation that greater distributed storage in the network may reduce the amount of long-distance communications. How do you feel about that?
comments?
So the question was around reducing long-distance communications. I think, maybe it actually comes down to where those aggregators are located. They don't always have to be sort of centralized systems, right? So I think some of the virtual power plant projects are actually exploring is different types of arrangements, whether they're decentralized or centralized, or where they're located, and what actually that means in terms of communications requirements and some of the issues and challenges that we're having. So.
And are batteries a competitor? So a community battery, is it a competitor to a VPP? Or
yes, it could be. Yeah, so it could be a community battery, or it could even be a large-scale generator. So they're, at the end of the day, they're all playing in the same market, almost in this situation. Yes. Yeah.
From a telco's point of view, I want to throw you back maybe 10 years and think about when people started thinking that Netflix, the amount of video that was going to come on board, was going to reduce the operability of the internet because of the amount of volume that was coming in. What happened? We adapted, right? We have new technologies, and although we have reached the, pretty much the end of Moore's law, we have a lot of new developments in kinds of technologies. I would point you to investigate photonics as a new way of understanding electrical signals, and that there may be some development in that area that would help to drive new, faster change and deliver new supply when demand is extremely high.
So we had a question down at the back here.
Thank you, Gary York. I've got a couple of questions. And maybe Jennifer, you'd be targeted more towards you. So we've got Inna talking about gigawatt scale projects going on out in the far northwest, which you don't have connectivity. So is part of the problem due to what's traditionally been mega scale networks now having to deal with micro scale networks, so that community level? And are there opportunities to use deep learning to maybe do some predictive modeling? So remove that latency by identifying those issues early and sending the signals out to individual homes and devices?
Yes, yes, and yes. Next question. So look, the whole idea of us being able to use AI or use deep learning, it's begun, but there's so much more potential. So doing that is one way of doing it. But the other thing is that what you mentioned about going to really large projects, and we haven't really put a lot of thought into the where yet. People put solar panels on ground across some of our best agricultural land. That does not make sense. Why not lift up the panel? Make shade, help. Honestly, the temperature is going to get to 45 degrees on a regular basis. Why don't we make shade? Right? It just is logical. So think about things. We tend, as a culture, we think about this as a product. Right? We think, okay, we'll go for hydrogen, or we'll go for solar, or but we don't consider where very often, and we don't consider how very often, and we don't consider how the people could benefit from what we do. So, for example, if you had, 100 square kilometres of solar panels, perhaps we could, draw some energy off, draw some heat off the back end, and use it to heat some water that might help us to build another industry more efficiently. There's a lot of cross benefits we could generate.
Just to add to Jennifer's point, also obviously we are looking to design those large projects, 50 gigawatt projects. Well, that's something that needs to go into the planning phase, because the majority of the generation is going to come from solar. So, and they are in the remote areas of WA, where there is plenty of sun, and potentially the agriculture sector will benefit from some of the initiatives that Jennifer has been talking to.
The key with that is not to make it too remote, because if it's too remote, the soil is not good enough. And so the key idea with carbon credits is that you have to be able to show improvement over time, right? That the soil has improved. So if you go too remote, you can't really do much with the desert, right? But if we look at the fringes, we look at the edges of opportunity here, we could find some areas where we could actually, push from what it was as a grassland, we can push it back, and then at a larger scale, we bring in it and put it close proximity to hydrogen, and we pull the things together. Even harnessing that water that was in part of the flood could be something that we do in the future if we think of managing and building communities better.
Jordan.
Yeah, so we have a couple of different questions online that I will try and combine for us. There's this question with the increase in complexity and interdependency of all these different systems, that the chance of local errors will happen, but of course there's likely to be a much larger chance of the cascading of wide-scale critical errors. So in the past, we've had this issue with a simple failure of an interconnect that has cascaded through the power system. But now that same failure could cascade through the communication system. So what thoughts do you guys have about that?
I listened to the earlier discussion, so the last Pearcey discussion about this, and there was a tendency to go, right, it's all part of one enormous system, and that has huge implications for the robustness and the reliability of the electricity system. But I would just like to put this thought out here that said, no, actually, it's probably simpler just to continue to think about these as separate systems, but that the participants in each system need to be envisaging, and I appreciate this is not the world's most efficient course of action, but they nevertheless need to be envisaging what their own backup plans are in the absence of electricity. Now, I'm just going back a long way in my career. I remember dealing with a customer who told us that they had diesel backup in the event that their gas went down. But then when challenged about this, they'd say, well, it was actually probably 15 years since they checked the diesel in the tank, which at this point was probably like tar. It was not a working plan. You need a working plan if you're a water authority or you're a telco or someone else immediately hanging off the electricity system for the failure of that system. And in some instances, those working plans are going to be non-renewable. It's in the same way that rural households have diesel generators. Then some of that is going to be not desperately attractive, not terribly green, stuff that robustly starts up when you need it to.
But you're right. But that's one of the areas where there's most innovation, new kinds of technologies that do the backup. So that you'll find that there's a lot of tech around that you're absolutely on point, is understanding that there is these things are going to happen. So what are we going to have and how are we going to understand it? The other thing I really want to talk about is the long duration energy storage. Make sure that we have a huge understanding of the volumes that we're talking about. So not just looking at, lithium-ion batteries, but different kinds of batteries, or maybe even, pumped hydro, or different systems that could be used as backup batteries for the system, so that we have a different, more robust backup rather than just small batteries, or having, as I say before, a hybrid of both. Making sure that we have the big and the little so that they all do their job.
I believe IEMA has got a system black start procedure that all of the generators have to follow. I don't know if you want to mention that sort of as a backup plan.
Yeah, but that's a backup plan for the whole of the system. And certainly, when you're looking at what the future grid could look like, there are increasing risks when it comes to some of the failures that could happen in various parts of the system, and what impact it could have to system-wide events like blackouts. Those procedures and protocols not only need to cover, what the power system needs to do to be able to detect and respond to those kind of events, but also, what the technologies that underpin those systems need to be able to keep up with as well. Yeah.
Dennis O'Hara, I have a hypothesis on the hydrogen scenario, for you to critique, if you wouldn't mind. My hypothesis is that the hydrogen scenarios will have negligible grid impact, at least initially. That there are a small number of very large projects designed to ship energy overseas, as hydrogen or ammonia or whatever, probably built in locations that suit those export markets, like the Pilbara or Queensland, where we already have significant export capability. And a very large project with very large energy needs in the Pilbara has no connection to the rest of the network. It could in Queensland, but it doesn't have to. They are very large engineering projects, like the Northwest Shelf, with very large social implications, including the ability to very large communities, which those projects actually have done in the past. But building them is an investment in achieving significant exports, not with grid impacts until they actually overflow to the community. The best mobile coverage ever got cost on a cruise was a Kimberley cruise, because all of the drilling stations out in the Northwest Shelf have mobile towers. And I'm sure these large-scale hydrogen projects will have spillover benefits, particularly if we take the social implications together. But my fundamental hypothesis is it actually doesn't impact the grid. They don't impact the grid at all, at least initially.
It's a new grid. Look at it as a new grid. But you're right. Those projects are not expected to be connected on the grid. And I've just got some figures in front of me, and again, it came from the integrated system plan, where IEMA sort of published where the demand is expected to come from under different scenarios. And the key difference is hydrogen consumption for export, and for the hydrogen superpower scenario, it adds up 816 terawatt hours. So you're sort of comparing 394 to 1278. That is primarily the difference, and it will be operating sort of outside the grid. But I think where it's quite relevant is you've got an opportunity to design that system, because there will be communities built around those projects. And that's where sort of the connections to Jennifer's topic. So how do you design the systems that, supports those projects but also benefits the community? So with the future in mind, with the future of, increased AI and digitalisation.
I also have to say that massive carbon credits would be a substantial export, and can just visualise the kangaroos on our big natural regenerative pasture there, and damn, so it looks like a tourist kind of place, and our tourist industry is worth $150 billion. What if we made it that $3 billion just because we did such a great job of integrating all of the new technologies in a sustainable way? Just because we're smart, that would be awesome.
So I combine a couple of other questions for you. And this goes back to some of the suggestions that Jennifer's been making about the reuse or the multi-use of land and assets. And there's an important consideration that's been raised is it's great to talk about that, but of course we need to understand what impact that's going to have. How would you see the scientific preparation? So if we're going to have multi-use of the land, are we sure that's actually going to be beneficial for the land? And related to that was another question, which was about the social impact. So it's one thing to be saying that we're going to build new communities somewhere where we're creating new massive assets, but couldn't we look at both the environmental impact of creating new infrastructure when we might in fact be redeploying new infrastructure into existing facilities that have been replaced, such as, for instance, a town based around coal-fired energy. So there are some social and environmental issues that are coming up.
Yeah, that was a question to me. Yes. So could we put them close? Absolutely. But let's put it smart, right? We don't have to put it on the ground. So look at how our wine industry could benefit from having shade on the vines, or whether our pastures, we've got hundreds of kilometres, thousands, millions maybe of kilometres of pasture in Australia, that why can't we distribute some of that on that land right now? Now, how will it work? So currently solar on ground and the use of raised solar, which has migrating solar panels, it's about 20% more to build, plus the structure underneath, right? But then the solar panels capture about 30% more than static panels. So you've got that tracking solar getting a bit more value. So that's economically the values there and the working. Research-wise, there are agrivoltaic projects across the world in California, Scottsdale, Florida. There are all projects with more than 1,500 acres being used for agrivoltaics quite easily, quite well. It doesn't need to be researched in a university. There are other examples across the world. But I think it would be very wise to run a simulation, put it on a model and look at the potential land uses and values that we could create. And we should be doing that with everything that we're doing, starting to see what are the options, how much is it going to cost, how are we going to get there, and what's the impact going to be. And if we take that as our first starting point, we're going to do a better job, rather than just thinking, oh, here's a product, where are we going to put it? Oh, well, he'll do. That's no way to do anything.
I might just add to that, just to that question around using existing infrastructure of retiring plant. That's already being looked at in various parts of the grid. The sort of southeast of Victoria is a clear example where you've got a fair bit of coal-fired plants either retiring or forecast to retire, and there are plans to look at installing, batteries and offshore wind farms to be able to have access to that infrastructure that's already existing. So, there are already sort of programs and
to your
plans
point,
to do that,
there's so much that's going to be done.
Yes.
It's not either or. We can do that and that.
Correct. Yeah.
Connection is too valuable a resource to waste. So the existing plants have massive connections to the grid, and when the plant goes, something else will go in and use the connection. But I do think it is worth reminding ourselves that the communities those new connections support will not be the size and scale of the communities that existed around the previous stations. The new stations' requirements post-construction phase are very much smaller. And for telecommunications discussion we've had means, of course, you can operate them remotely. You can dispatch the crew to fix them from a remote location. So the people doing the dispatch may be hundreds of kilometres away from the actual equipment. And that's a loss relative to the old style where the control room was in the generator. Oh, hang on, we've got a question in the room.
Thank you, Bill Wood. Nikosha, you talked about the need for data exchange and intermediary functions, and seems that that's going to be a pretty critical component for a future interconnected grid, and also one that's going to constitute very critical infrastructure. I presume that any such facilities would need to be market neutral. It goes without saying that realising these sorts of functions will be massive, not only technical but governance and particularly security challenges. So I'm kind of wondering what the panel's view might be on, both whose position, kind of leadership here is going to be critical, or these things are just not going to happen, whatever they constitute. So, who do you think is best positioned to both kind of lead the initiatives to make these things happen, and then, as a follow-on to that, operate these pieces of infrastructure?
May I?
It's very difficult for Nanushka, I think, to put her hand up and say, my organisation.
Yeah, so leading, can we separate leading and operating, or envisaging and operating? Because it's very difficult for one institution that has a product or defined interests to be the envisager of the future. So we need to have a group of people who actually have a bigger view, right? Because if an energy company comes along to install a grid, they're just going to install a grid, and on the ground is, if you don't think about it, it is totally the cheapest, best, quickest option. Let's do it. But if you had a bigger vision, maybe some people who are more sustainable, who are more venture investors, people who see a bigger picture, might own those projects, and they might be the leader, the envisagers of that initiative. So then the operators will operate, of course. But I think that's a challenge, Bill, and I'm not surprised that a great question like that came from you. Because that's the challenge. Where is the leadership going to be? I mean, if our politicians don't really know or understand the system, how are they going to get that viewpoint of this interconnectivity?
Ina, you might, in your previous life in the Asia Pacific, you might also have something to say about Australia's position in the ecosystem of the technology. I mean, we are primarily a technology importer in this space.
Yeah, so obviously grid connection for the projects was the single biggest risk for a project. And customers would start engagement with OEM 2 years before they want to actually go ahead with the project, before they want to commit the funds to invest in it, because connection was so important. And it's highly regulated. However, when we talk about, for example, hydrogen scenario, you're talking about the projects, massive projects the size of half the grid now, that are actually not going to be regulated, that are going to be privately owned. And it's a good question, because I don't think there is a solution now who's going to regulate it. If you look at the mining industry, I mean, BHP owns part of the grid there. Rio owns part of the grid, so to supply their own assets. So there is, AEMA does not regulate those. But yeah, definitely an interesting question, and definitely something for the industry to consider when, this grid is not going to be 500 or 1,000 megawatts, when this grid is going to be 50 gigawatts. So it's a very different scale and very different question going forward.
And it is an interesting institutional question, because Ina's right. The existing energy market operators and regulators are definitionally attached to the coverage of the grid that we have. And so if you're in a situation where you're building a greenfields grid and you've got the relevant, probably state permissions to do so, then AEMO, the AEMC, the State Essential Services Commission, none of them have anything to say about the performance, the design, the operation of that. Now, you might have an act which then refers to various, pulls in various requirements, but they won't be the requirements of the regulated electricity sector, which very much has the footprint of what we had and what we build out from it, not the new stuff. Yep. Jennifer, were you frantic to say something?
No. I'm thinking what a great conversation it's been, actually.
And just going back to that point, that it's also a global issue. So in the energy sector, that a lot of the sort of market and system operators around the world are actually getting together to share learnings and knowledge around what each other's experiencing. Some of the roadmaps that you see on the public domain from the Global Power System Transformation groups that bring together all sort of the heads of different countries are looking at these problems collectively, and I wonder to what extent the ICT sector can actually be coming in together with that as well to look at it collectively.
Jordan.
Excellent. Well, first of all, everybody, please, let's say thank you to the panel for everything. And in terms of thank you, go to the next slide. I'd just like to say thank you to our supporting partners, the University of Melbourne, the Monash University, and of course here today with the ACS, all being very supportive of this program. And so just to highlight for all of you again, Australia 4.0 is a series of national discussions. We've got 7 national discussions running throughout the country. This is one of 2 hybrid sessions. The others have all been fully online. We have several more to go. So the next session is session number 5, which is all about the consumer grid. And we'd encourage you to go to the Pearcey website and register. All of these events are free, and they will culminate on October 30 in Sydney with a half-day summit, where we're going to be working together to extract the insights from everything that we've heard at each of these sessions, and hopefully summarise them in a way that's going to be useful to the industry, to government, to all the participants. And in doing that, I just sort of reflect a few of the things I heard today that might be helpful to remember. We were talking in particular about the communications channel, the internet channel, and there is a significant challenge, it seems, in synchronising the communications between the edge of the network and the core of the network, and particularly the market operations, because of latencies and new technology differentiations. And then there's a whole lot of new types of measurement that are going to be introduced into the network, not just because of new energy modes and renewable energies, but also because we're going to have new ways of monitoring the energy system itself. And with that, we'll have new data, we'll have new integration challenges, and we will have new derivatives of that will lead to benefits, whether it be in something as critical as cybersecurity or in other areas that we can use to benefit both the energy grid and the broader community. I think it was really interesting to see the slide where we saw that electric vehicles are going to be such a huge piece of the transition. But if we think about electric vehicles and communications, and the point was made by one of the speakers that the technology being used for electric vehicles and communications is not as straightforward as some people might think. But if we now think about how many more services are going to be derived through electric vehicles, then we're going to have to see a whole lot of new capabilities, new infrastructure, new bandwidth, new security, and new communication protocols. So there's an enormous amount of opportunity in the electric vehicle space for the ICT sector if we look at electric vehicles and their charging networks as a platform, the same way mobile phones are a platform. So with that, I'd like to say thank you to everybody for joining us today, and we'll set you free. And certainly for the people here in the room, I'd encourage you to step out. There's a light lunch for us to enjoy as we continue the conversation. So thank you all very much for coming. Thank you again to our speakers today, and we look forward to seeing you at the session number 5.